Hello everyone, welcome to my YouTube channel Easy Way to Learn. I'm Shraddha Tripathi and in today's lecture we'll be dealing with some basic concepts of chemistry which is class 11 topic. So let's get started, remain focused and follow the lecture. This topic begins with the nature of matter. So you have already studied in your lower classes the definition of matter, that anything that has mass and occupies space. So anything that has mass and occupies space is called matter. So this is a simple definition that you have already studied in your lower classes. See, matter is present in three physical states: solid, liquid and gases. And what are the properties when the matter exists in these three states is also part of lower classes. See, solids have definite volume and definite shape. Liquids have definite volume but no definite shape. Gases have neither definite volume nor definite shape. So these are few of the things that is coming and it is just a repetition. So conversion of three forms of matter is already known to you, that solid changes to liquid, liquid to gases on heating, and on cooling it reverses back, that is gases to liquid and liquid to solid. Next we come to classification of matter. This is also a part of class 9 syllabus that you have already studied. Classified as mixture or pure substances. Again, mixture is either heterogeneous or homogeneous. So heterogeneous mixtures are those that have different composition, that is not the composition is not same throughout. Homogeneous mixtures composition is same throughout. For example, sugar dissolved in water is example of homogeneous mixture, while chalk water is example of heterogeneous mixture. So this is also part of lower classes. So matter is, let me write down here. See, matter is divided into mixture and pure substances. Pure substances. Again, mixtures are of two types: homogeneous and heterogeneous mixture. Homogeneous and heterogeneous. Homogeneous means composition is same throughout the mixture. Composition is uniform. See, the components are uniformly distributed throughout the bulk of the mixture. So here composition is uniform. For example, sugar solution. And in heterogeneous, composition is not uniform. You can take the example of chalk and water, chalk plus water, or sand and sugar. So this must be clear that mixture are of two types. Then in pure substances, if we talk about pure substances, the definition says that the constant particle of pure substance have fixed composition. So here in pure substances composition is fixed, whereas in mixture composition is not fixed. So pure substances will have a unique formula or a symbol, whereas mixtures do not have any formula or any symbol because composition is varying. Okay, so in pure substances, see, have fixed composition like copper, gold, silver, glucose are the examples of pure substances. Here pure means that it is only one kind of substance is present. Okay. Okay. Pure substances are again classified into elements and compounds. Elements and compounds. Okay, elements are made up of only one kind of atoms. So the smallest unit of element is atom. So elements are made up of atoms, whereas compounds, their smallest unit is molecules. Are made up of molecules. Another point of difference will be that elements are represented by symbols. Elements are represented by symbols. For example, for copper, we write Cu. So this is symbol for copper. Similarly, here we have formula for the compounds, for the molecules. So these compounds are represented by molecules which have fixed formula, are represented by formula. For example, water. So there is fixed composition, that is, it is represented by H2NO. So hydrogen and oxygen atoms are present in the ratio of 2:1. That is, they have a fixed composition here. Another point is okay, compounds are made up of either similar atoms or dissimilar atoms. For example, in case of water, see, hydrogen and oxygen, there are two atoms which are dissimilar. So here it can be dissimilar, or for example, you take oxygen gas, which is made up of two atoms of oxygen. So it is made up of similar atoms. So here molecules are either made up of similar types of atoms or dissimilar type of atom. Let's see properties of matter. See, properties of matter and their measurements. See, physical and chemical properties. These are two properties which are used to define or explain any matter or the nature of matter. See, physical properties are like color, odor, melting point, boiling point, density. So these can be easily measured. See, melting point, boiling point, density, refractive index. And chemical properties are those for which some chemical reaction need to happen. For example, combustibility, reactivity of acids and bases, that is acidity and basicity. So these are the chemical properties which are observed and during experiment. And obviously, if these properties, some of these properties can be measured. So measurement of the physical properties. So there is a system of measurement that is SI system which is followed throughout the world. See, SI system has 7 basic units which are mentioned here, and rest units are derived units. So what is meant by basic units and derived units, that I'll explain it here. See, basic units are length, mass, time, electric current, temperature, amount of substance, that is we calculate in moles, then luminous intensity and candela. Okay, with the help of these 7 basic units, we can derive other units. For example, with the help of length, see, length is the basic unit, and with the help of length we can find volume of cube. See, so that is length into length into length. So unit will be, if we take a unit of length, meters, so it will be meter into meter into meter, that is meter cube. So this is derived unit, that is volume is a derived unit, whereas length is basic unit, that is helping us to obtain some other units of other physical quantities. For example, if we take density, density is a derived unit. See, density, it is defined as mass per unit volume, that is mass upon volume. See, we know mass is again a basic unit which is measured in kg, SI unit is kg, volume is a derived unit measured in meter cube. So this kg per meter cube is a derived unit. To the prefixes used in SI system, which is again very much important and very essential that you must remember it. So prefixes used in SI system are, these are multiple prefixes that are used. See, you begin remembering from here. Divide this table into 2 parts. See, our baseline is deca, 10. Now, if we see all the units above this, they are smaller units. We are going towards smaller units. And if we are moving downwards, we are moving towards more higher units. See, here after deca comes deci, centi, millimeter. These are few of the units that we have already used them in maths so much. But rest of the units are not that frequently used, and the easy way to remember them is, see, all are the multiples of 3. See, 3 2 is 6, 3 9, 3 4 is 12, 3 15, 3 6 18, 3 7 is 21, 3 8 is 24. So after 1 and 2, you remember that they are multiples of 3. Again, -6, and they all end with O. Exception is deci, centi and milli. After that, they are all ending in O. These are few of the hints that you must remember, or that will make this learning of this table easier. See, micro, nano, pico, femto, atto, zepto and yocto. So zepto is 10 raised to the power minus 21. Okay. Now, if we come to these lower units, these units which are written below deca. See, hecto 10 raised to the power 2 kilo. Besides hecto and kilo, all are ending in A. See, again, remember the multiples of 3. 3 2 is 6, 9, 3 4 12, 15, 18, 21 and 24. Now, all the exponents are positive, and here all the exponents are negative. So again, you have to remember these names. 10 raised to the power 6 is mega, minus 6 was micro, and plus 6 is mega. 10 raised to the power 9 is giga, 10 raised to minus 9 is nano. 10 raised to 12 is tera, then peta, exa, zeta and iota. So this way you have to remember the table for conversion of units. Let's see difference between mass and weight. See, this is also part of your lower classes. Mass is the amount of matter that is present and weight is the force exerted by gravity on the object. So if we see difference, what are the points of difference? Mass and weight. See, one of the point is already mentioned here, that it is the amount of substance that is present and weight is the force. So first is, this is amount of substance or matter that is present. And weight is basically the force exerted by the gravity on that matter. So unit of mass will be kg, and here unit of force is Newton, represented by capital N. Newton is the name of scientist. So name of the scientist is represented by first alphabet and that too in capital. Another important point of difference is that mass remains constant. It does not vary from place to place, whereas weight varies from place to place. That is, if you measure something at poles and something at equator, then the weight will vary. Same amount of substance will give different weights at different places. Or very common example is, if you weigh a substance on earth and you weigh a substance on moon, obviously the same amount of substance will weigh smaller, because gravity is 1/6 of the earth. So mass remains constant, does not depends on the place. See, remains constant, whereas weight varies from place to place. Varies from place to place. So these are few of the point of differences, which is again a repetition. Okay, next we come to units of measurement. We have 3 units of measurement, which are degree Celsius, Fahrenheit and Kelvin. So it is important that you must know conversion of each. So again, this is again repetition. See, degree Celsius and degree Fahrenheit are again related. See, Fahrenheit is equal to 9 upon 5 degree Celsius plus 32. See, what does it mean? If you take 0 degree Celsius, so Fahrenheit will be, see, 9 upon 5 multiplied by 0 plus 32. So this term becomes 0 and you are left with 32. That is 0 degree Celsius is 32 degree Fahrenheit. So 0 degree Celsius is equal to 32 degree Fahrenheit. So if we see here Celsius and Fahrenheit, so freezing point of water is 0 degree Celsius, and on the Fahrenheit scale, what we are getting? 32 degree Fahrenheit. Similarly, in case of Kelvin, Kelvin is degree Celsius plus 273.15. Again, if you keep Celsius 0 degree, so Kelvin scale will begin with 273.15. So again 0 degree Celsius is equal to 273.15 Kelvin. So these two formulas must be clear and you must remember them for conversion. So we do not write degree with Kelvin. So this is the scientific unit of measurement. Now let's see what is meant by scientific notation. This you have also studied in mathematics in lower classes. So it is basically used to write the number in simpler way. So if our number is too big or too small and it is having lots of zeros, to make a mathematical operation, that is addition, subtraction, multiplication and division simpler, we write the number with the help of exponents. See here the number is written and followed by exponent, that is 10 raised to the power 2. And this is the way we write, and this is called scientific notation. Basically here number is written like n into 10 raised to the power n, where small n is the exponent and n is any number between 1 and 9.99, that is between 1 and 10. So for example, if you have the number, see 28000, let's see, this is the number and we have to convert it into scientific notation. So this numerical value, that is capital N, should lie between 1 and 10. So what we'll do, we'll place a decimal here, that is let's make this 2.80004. Now since we have placed the decimal by moving to the left, so what we'll do, we'll 1 2 3 4 5, we'll write 10 raised to the power 5. So this is the scientific notation, that is writing the number and the numerical value should lie between 1 and 9.99 followed by 10 raised to the power n. Similarly, if we have any smaller number, for example 0.00003, so what we'll do, we'll write 3.0 into, now we are removing the decimal and shifting to the right. If we are shifting to the right, then 1 2 3 4 5 places, so it is 10 raised to the power minus 5. So when you are moving towards the left, you increase the power, and when you are moving towards the right, you decrease the power. See, it can also be explained. If you don't want to remember the trick, you can do it mathematically. For example, for this number, we can write this number as 1 2 3 4 5, 10 raised to the power 5. Now what the simple way is, write 3 into 10 raised to the power minus 5. This is the way of writing. Similarly, in this case, what you do, if we take a number and we have a number 2800004. Now you have to convert into scientific notation. So the easy way is, if we are placing the decimal and moving towards the left, then what we'll do, see 1 2 3 4 5, so we are moving 5 places, so we write 2.80004 into 10 raised to the power 5. That is, if you are moving towards left, then we increase the exponent, that is 10 raised to the power 5 here. See, this is the faster way of doing and remembering the rule. And mathematically see how it is solved. So we have to place the decimal after 2. So what we do, we divide this by 1, 2, 3, 4, 5. 0, 0, 0, 4 divided by 1 followed by 5 zeros. See, if you are dividing a number, then you have to multiply the number by same denominator. See, 1 followed by 5 zeros. So, this part, this denominator is now used to place the decimal. So, what you get? 2.80004 into 10 raised to the power 5. So, either you remember this simple trick or you can do it mathematically. See, I'll take another example. See, if we have a smaller number like 0.000003 and we have to convert into scientific notation. So what we are doing, we have to move decimal to the right. So what we do, then we increase the exponent. See, 1, 2, 3, 4, 5, 6. We are moving decimal 6 places to the right. So it will be 10 raised to the power minus 6. Now let's see how it is done mathematically. So you write 3 upon 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Or you write 3 upon 10 raised to the power 6 or 3 into 10 raised to the power minus 6. Take this 10 raised to the power 6 in denominator to the numerator. So using the laws of exponent, this 6 will become minus 6 when it goes to the numerator. So either you do it mathematically as you have learned in the smaller classes, or you just use this trick that when we are moving the decimal to the left, we'll increase the exponent. See, I'll write down. See, if this decimal is moved towards left, you increase the exponent. And when you move the decimal to the right, you decrease the exponent. So this is the easy way of remembering. Now let's see what is meant by significant figures. To understand this, we have to first understand what is uncertainty in the measurement. See, every experimental measurement has certain amount of uncertainty associated with it. This is because of the limitation of the measuring instrument and also the skill of a person. The example which is given to explain the essence of uncertainty is, if we measure a mass with the help of platform balance and the same mass is measured with the help of analytical balance. So what's the difference? Let's see. If we measure it with the help of platform balance, the value, I'm taking the value which is mentioned in the book. See, it is given if the mass is measured, value comes out to be 9.4 gram with the help of platform balance. Similarly, same mass is measured with analytical balance. The value comes out to be 9.4213 grams. This is with the help of analytical balance. See, what is the difference between the two values? See, this value that is measured with analytical balance is slightly higher than the one measured with platform balance. Now, the uncertainty in the experimental or the calculated value is indicated with the help of significant figures. So what are significant figures? See, significant figures are meaningful digits which express the digits at certain values are certain and the last value is uncertain. Or certain significant figures are meaningful digits which are known with certainty plus one which is estimated or uncertain. That is, if we take this first value 9.4, here 9 is certain but 4 after the decimal is uncertain. So the last digit of the value is uncertain. Similarly, if we take this example, so 9.421, these are certain digits and the last digit, that is 3, this is uncertain. So significant figures are meaningful and the uncertainty is plus minus 1. This is understood if it is not mentioned. We assume the uncertainty is plus minus 1. Now let's see the rules which help us to determine significant figures. Okay. First rule says all non-zero digits are significant. See, example is 285 centimeters. Here 2, 8 and 5. These are the three digits. Hence, it has three significant figures. So, all non-zero digits, we can take another example also, 189, or let's add few more values, 5, 6. So now 1, 2, 3, 4, 5. There are 5 digits. So there are 5 significant figures. 5 significant figures. So first rule says that all non-zero digits are significant. Okay. Here 0.25, again 25. There are 2 digits, hence there are 2 significant figures. Second rule says zeros preceding to first non-zero digits are not significant. That is, if we take the example like 0.009. So these zeros which are preceding the non-zero number are not significant. That is, these zeros are not significant. Hence, number of significant figures will be 1. That is here 9. This non-zero digit is significant. See, 0.03 has one significant figure. So 0 preceding the non-zero digit number is not taken into account. Again here 0.0052. Again there are 2 significant figures, 5 and 2. These zeros preceding the non-zero digit number are not considered. They are just used to place or tell the position of the decimal. Okay. Third rule says 0 between two non-zeros are significant. Okay. So now let's take one more example. See, if I write a number 10028. Now these zeros will be considered significant because they lie between non-zero digits. Here 1 and 2. So if the zeros lie between non-zero digits, they are significant. Hence the number of significant figures will be 1, 2, 3, 4, 5. Again 5 significant figures. See, another rule is, or the fourth point is, zeros at the end are not significant. See, if I write a number 12800, these terminal zeros are not significant if there is no decimal placed. So here we'll write there are 3 significant figures these terminal zeros will not be considered. Again, if I write a number 2800, then a decimal, now these two zeros will be considered as a significant figure. Okay. So here 1, 2, 3, 4, 5 significant figures. So zeros at the end or right of a number are significant provided they are on the right side of the decimal. Another example, see, if I write a number 0.2000, so now these zeros will be considered significant because they are on the right of the decimal and they are after a non-zero digit. See what the rule says. See, if zeros at the end or right of a number are significant provided they are on the right side of the decimal. So in this particular example, two things must be considered, that these zeros are on the right of the number and also on the right of the decimal. Hence, there are 1, 2, 3, 4, 4 significant figures. And the last rule says, see, or let's see this example also. See, for example, 100, it has only one significant figure, 100. One followed by two zeros. Again, here in this case, these terminal zeros are non-significant. Hence, it has one significant figure. And put a decimal. Now it has three significant figures. 100.0. Now this has four significant figures. So you must remember when the zeros are considered as significant and when they are not considered as significant. So this rule number 4 is very important. Okay, next we come to next rule. See, this rule, last rule says counting the number of digits, for example, 2 balls 20x have infinite significant figures. If we are counting number of objects, then it will have infinite number of significant figures. Means 2 balls you can write in this manner, 2.000 plus any number of zeros, it will hardly matter. Similarly, 20, after 20, place a decimal followed by 0. So you can place any number of zeros. Hence, while counting number of objects, significant figures are infinite. Okay, and all the numbers written in scientific notation will have, all the digits will be significant. So numbers written in scientific notation will have all the digits significant. For example, 4.01, here there are three significant figures. Similarly, 8.256, there are four significant figures. So these are the rules which you must practice it. Now let's see what is dimensional analysis. See, often while calculating, we need to convert unit in one system to another. And this conversion is carried out or it is accomplished and is called dimensional analysis. For example, you have often converted meter to centimeter or vice versa. See, if you are given convert 5 meter to centimeters. So we know that conversion factor is 1 meter is equal to 100 centimeter. So we can write 1 meter upon 100 centimeter is equal to 1. We can also write 100 centimeter upon 1 meter it is also equal to 1. And this conversion factor, that is this one and this, it is called unit factor. That is, it will only help to convert the unit without affecting the answer or without affecting the result. Similarly, this example is taken, convert 3 inches into centimeter. So here again our conversion factor is that 1 inch is equal to 2.54 centimeters. See, now let's see this example which is given here. See, now 1 inch is equal to 2.54 centimeter. Again, this can be written as 1 inch upon 2.54 centimeter. This will equal to 1, or you can reverse and write 2.54 centimeter upon 1 inch. So these, if you write in this form, it is called unit factor. Again, now we have to convert 3 inches into centimeter. So you need to convert 3 inch into centimeter. Now which conversion factor will you select? See, we have to report our answer in centimeters. So the numerator should have centimeter. So multiply 3 by 2.54. See, upon 1 inch, and here it is also in inch. So inch and inch will cancel out and the answer will come out in centimeters. So whatever result you want, you convert or you multiply with that particular conversion factor. So we have a result, we need an answer in centimeters, hence we will select this as the unit factor. Okay. Now let's see another example. Okay, this is important, that is conversion of liter into meter cube. This is often asked and we come across this conversion very often. So now let's understand how it is done. So you must know the conversion of liter into meter cube. Now for clarity's sake, I'll explain it here. See, 1 centimeter cube is equal to 1 milliliter. Okay. Now if we have 1000 centimeter cube, that is 10 centimeter multiplied by 10 centimeter into 10 centimeter. So this will be equal to 1000 milliliter, or you can write 1000 centimeter cube is equal to 1000 milliliter, and we know 1000 milliliter is 1 liter. Okay, conversion of centimeter to meter is already known. So we can convert this centimeter cube to meter cube. So now use this relationship, that 100 centimeter is equal to 1 meter. Use this information. Now divide 10 centimeter by 100, then 10 centimeter by 100 and 10 centimeter by 100. You will get meter cube. Now what we get here, and this is equal to 1 liter, we have already calculated. Now here what we get, see, 1 upon 1000 meter cube is equal to 1 liter, or you can write 10 raised to the power minus 3 meter cube is equal to 1 liter. Now this is our conversion factor. Now you have to convert 2 liter into meter cube. So 1 liter is equal to 10 raised to the power minus 3 meter cube. So our unit factor will be 10 raised to the power 3 meter cube upon 1 liter into 2 liter multiplied by 2 liter. So this liter will cancel out and answer is 2 into 10 raised to the power minus 3 meter cube. And this is your answer. Now let's see what are the rules for rounding off the numbers. See, now here we'll see few of the rules which are mentioned here. See, the first rule says if the rightmost digit is to be removed is more than 5, then we add 1 to the preceding one. For example, see, it is given 1.386. And here, if we have to remove 6, what we do, if this number, the last digit is more than 5, we add 1 to the preceding number, that is number before 6. So our answer will be 1.39. So rounding off 1.386 will give you 1.39. Okay. Second rule says if the rightmost digit to be removed is less than 5, then the preceding number is not changed. So according to second rule, see the example which is taken is 4.334. Now this last digit is less than 5. So we'll not do anything to this preceding number, that is 3. So our answer will be reported as 4.33. Okay. Now let's come to the next rule, which is, because first two rules you have already used in lower class, but the third rule is something that you are learning in this class. See, if the rightmost digit to be removed is 5, then the preceding number is not changed if it is even number. See, if you have a number 6.285, see, this number is equal to 5 and the preceding number is even number. So this number is not changed and you'll report your answer as 6.28. And if you have number 6.235, so if the preceding number is odd, then we add 1 to the preceding number and the answer is reported as 6.24. So this last rule is important. See, if the rightmost digit to be removed is 5, then the preceding number is not changed if it is even, but it is increased by 1 if it is odd. So example that is taken is 6.35 and after rounding off it becomes 6.4. But however, if the number is 6.25, we are not changing the preceding number and the round off number is 6.2. Hope you understood the topic well. Please like, share and subscribe. And in the coming video, I'll take up questions based on significant figures. So catch up with me. Thank you so much.